Hello my dear viewer, welcome to another mathematics lesson, Form 4. The topic which we've been discussing is differentiation. In our last lesson, we learned how to find the gradient of a curve at a particular point. That is what we learned, how to find the gradient of a curve at a particular point. And in that lesson, I gave two questions as assignment. One of them is this one here, find dy dx. For that, where we have brackets, we learned that also in our previous lesson. And I hope you've tried, and if you've done it, then you can check whether with me whether you have correctly done it or not. So if this is the function, then dy dx will be, first you remove the brackets. That is the first thing. Before you even go to dy dx, you remove the brackets. What we apply here is what we learned in Form 2, the topic of quadratic equations and expressions. There is this quadratic identity you learned in Form 2, a squared minus b squared is equal to a plus b, a minus b. That is what you apply here, because this is x squared minus 1, which can also be written as x squared minus 1 squared. Remember, 1 squared is 1. So if you write it as x squared minus 1 squared, it looks like this equation. So you can write now with two brackets like this. So you are factorizing. You are actually factorizing. So when you factorize this, you will get x plus 1, x minus 1. So that is how you write that expression. So let us now write this expression in this way. So we shall have y is equal to x, there is an x outside the bracket, then we have x plus 1, x minus 1, everything over x plus 1. Now you can do some cancelling. That is, we have x plus 1 in the denominator here, which can cancel with x plus 1 there in the numerator. So when you cancel, you will remain with y is equal to x times x minus 1. Again, we have a bracket, so we have not completely removed the bracket. So we still have a bracket which must be removed before differentiation. I remember in that lesson I said brackets must be removed before you do differentiation. So we can now remove brackets here simply by multiplying x by x, that is x squared, then minus x times 1, which is x. So we have now that expression without brackets. So remember, the whole of this has been simplified to this. So we have just simplified. So now we can differentiate this. When it is like that, we can differentiate. So let us find dy dx. Dy dx here will be 2x 1, which we don't need to write, minus, if you differentiate that, you get minus 1. So that is the derivative of this equation. So dy dx equals 2x minus 1. So that is the derivative, and I want to repeat that derivative, derived function, and gradient function all mean the same thing. We have gradient function, can call this gradient function, we can call it the derived function, we can also call it the derivative. So that is the derivative for that equation. Then there is a question 2 which I gave as assignment. Let's look at question 2. The question 2 which I gave as assignment is find the gradient of the curve y is equal to x power 5 minus 7x plus 3 at 0, 3. Find the gradient of this curve at that point. Remember, we say that gradient of a curve keeps on changing. Gradient at this point is not the same as gradient at another point of the same curve. It keeps on changing. So at this point, we have a particular gradient. So, and to get the gradient, we must first of all find the gradient function, dy dx. Dy dx here will be 5x raised to power 4 minus 7. Full stop. And I'm sure by now you know how to find gradient function of any equation. So we have the gradient function here is 5x power 4 minus 7. Now, this is the gradient of the curve. This will give you the gradient of this curve at any point. This is the general gradient of that curve, or the gradient function. Now, at this particular point, what will be the gradient? So the gradient at 0, 3 is, you now come with, you use your x coordinate, because here in the gradient function we have x. You just replace x with the value of the x coordinate, which is 0. So we shall have 5 times 0 raised to the power 4 minus 7. What is that, my dear Anna? 5 times 0 power 4 is 0. 0 power 4 is 0, and then 5 times 0 is just 0. Then minus 7, 0 minus 7 is negative 7. So that is the gradient of this curve at that point 0, 3. So that is what we learned in our previous lesson, and that was the assignment. Now in today's lesson, we are going to learn how to find the equation of a tangent to a curve at a particular point. Remember I said that for a curve, the gradient keeps on changing. And at a particular point, there is a particular gradient. And if you draw a tangent to that curve at that point, that tangent will have that gradient of the curve at that point. For example, let me just draw a sketch. Let's say this is our curve, and we want to get the gradient at that point. Gradient at this point, let's say A, and at this point is not the same. Is not the same. At any point, any different point on the curve, the gradient is different. So let's say, let's take B as an example. So the gradient of this curve at this point is equal to the gradient of the tangent. Remember, the tangent of a curve is a straight line, which touches the curve at only one point, like that. So this is the point, this is the tangent. That is called a tangent. You learned about tangents in form 3. So if this is the curve and this is a point, the gradient of the curve at this point is equal to the gradient of this tangent. Remember, a tangent is a straight line and it has a constant gradient. Now, so that concept is what you are going to apply in finding the equation of that tangent. Since the tangent is a straight line, you know that the equation of a straight line is in the form y is equal to mx plus c. You learned that in form 2 and also form 1, I think. So let's look at an example. So we say, before we look at our first example, we say that the gradient of a curve is the same as is the same as the gradient of the tangent to the curve. At that point, very important, that is the most important point, the gradient of the curve, of any curve, at some point, is the same as the gradient of the tangent to that curve at that particular point. So let's look at an example. Find the equation of the tangent to the curve y is equal to x cubed minus 2x plus 4 at 1, 3. That is the question. Find the equation of the tangent to this curve at the point 1, 3. Find the equation of the tangent to this curve at that point. So what are we supposed to do? Step number 1, we differentiate in order to get gradient function, and then that gradient function will give us gradient of this curve at that particular point. And remember, that gradient at that point is the same as the gradient of the tangent. That's what we say. So after getting the gradient of the tangent, since the tangent is a straight line, for a straight line, if you have been given the gradient and you know a point on that line, you should be able to get the equation of the line. So you can now use the concepts you learned in form 1, I don't know if it's form 1 or 2, about equations of straight line. If you have a point on the line, because this point is already on the tangent, so, and then you have your gradient which you obtained, then you can find the equation of the straight line, that is the tangent. So let us differentiate. Define dy dx. Dy dx equals 3x squared minus 2, full stop. 3x squared minus 2. This is the gradient function of this curve at any point. Now, at point 1, 3, what is the gradient? At that point 1, 3, what would be the gradient? We now apply what we learned in our previous lesson to get this. You replace x with 1. The x coordinate here is 1, so you replace x with 1. So we have 3 times 1 squared minus 2. That gives you 1. Because 3 times 1 squared is 3. 3 minus 2 is 1. So the gradient of this curve at 1, 3 is 1. What does that mean? It means that the gradient of our tangent is also 1. So we know the gradient of that straight line tangent is 1, and the tangent passes through 1, 3. So how can we get the equation? How can we get the equation? We have gradient 1, and then it is passing through 1, 3. I know you know how to find the equation. I will remind you, take a point, a general point xy, and the point 1, 3. and the change in y over change in x is gradient. So change in y is y minus 3 over change in x minus 3 equals, sorry, not x minus 3, x minus 1 equals, this is gradient, and our gradient is 1, so equals to 1. Here, you can say y minus 3 over x minus 3, or you can also say 3 minus y over 1 minus x. It will still be the same, whether you start with this or you start with this. So it can be y minus 3, the way we have done, over x minus 1, or 3 minus y over 1 minus x is equal to 1. In both cases, it should be equal to 1, and the final answer or the final equation of that, the equation which you are going to get will be the same. So let us now simplify that. Already this is the equation of the line, but we have to simplify and write in the format y is equal to mx plus c. Whenever you are asked for an equation, it's good to write in this format. If you leave in this format, no. As an examiner, I'm telling you this now as an examiner. When we mark, we don't give you the mark for equation at this stage. At least you should simplify. So you can simplify by multiplying both sides by x minus 1. If you multiply this side by x minus 1, this one disappears. Then multiply that side by x. So we shall have, on this side we shall have y minus 3 equals 1 x minus 1. Then simplify. We shall have y minus 3, let me write here, y minus 3 equals x minus 1. Y minus 3 equals x minus 1. So these are like terms. So you add 3 on both sides, we shall have y equals x minus 1 plus 3, which gives you y equals x minus 1 plus 3. I hope you remember your integers in form 1. Minus 1 plus 3 is plus 2. So that is the equation of that tangent. Y is equal to x plus 2. Y is equal to x plus 2. Y is equal to x plus 2. Let's look at another example, my dear learner. I just remembered that I did not write the subtopic for today. It is equation of tangent to a curve. Equation of tangent to a curve. That's what we are discussing today. How to find equation of a tangent to a curve. And we have done example 1. Let's go to example 2. Find the equation of the tangent to the curve y is equal to x cubed plus 3x squared minus 3 at x is equal to 2. Find the equation of the tangent to the curve y is equal to x cubed plus 3x squared minus 3 at x is equal to 2. Again, let's follow the procedure. Step number 1, you must find gradient function by differentiating. So you find dy dx. dy dx here will be 3x squared plus 6x. 3x squared plus 6x full stop. And then at this point, what will be the gradient of the curve? Before we go to the tangent, we must find the gradient of the curve. So at x is equal to 2, gradient of the curve is, we have been given value of x already. That point on the curve where x is equal to 2, what is the gradient of the curve? So x is 2. So you just replace x with 2. So you have 3 times 2 squared, 3 times 2 squared, plus 6 times 2. 3 times 2 squared. 2 squared is 4. 3 times 4 is 12. Then 6 times 2 is 12 also. So 12 plus 12. Remember God mass, you multiply first, then you add later. So this is 12 plus 12, which is 24. So that is the gradient of the curve, this curve at this point. That gradient is also the same as the gradient of the tangent we are looking for. It's also the same as the gradient of the tangent we are looking for. It is also the same as the gradient of the tangent we are looking for. Now, we must find the value of y, because for you to get equation of a straight line, you require, like in the first example, you require the gradient of the line and a point in coordinate form, x coordinate and y coordinate. But now here, it's a bit different. We've been given x coordinate. We have not been given the y coordinate. So how do you get the y coordinate? The point should be 2 and a value for y coordinate, which we don't know, we've not been given. So we must find that y coordinate. And how do you get the y coordinate? You use the original equation. Y is equal to this. All of this. So you just replace x with 2, then you get y. Don't use this because this is dy dx, this is not y. We are looking for y, not dy dx. So you replace 2 here to get the y coordinate. So at x is equal to 2, y will be equal to 2 power 3 plus 3 times 2 squared, 3 times 2 squared minus 3. So that is, this is 8. 2 power 3, remember, is 8. 2 power 3 is 8. Plus 3 times 2 squared is 3 times 4, which is 12. This is plus 12. Then minus 3. That gives you 8 plus 12 is 20. Minus 3, 17. So the y coordinate is 17. So the point we are looking for, the point we were given is 3, 17. That is the point. 3, 17. We have obtained, no, 2, sorry, not 3. It's 2. 2, 17. So that is the point which we have, and we already have the gradient of the curve, of the tangent, which is 24. Gradient of the tangent is 24. Now we can get the equation of the tangent, because remember again, a tangent is a straight line. For a straight line, if you have a point on the line and the gradient, you should be able to get the equation of the curve. Using, we have 2, 17, and then x, y, a general point. then you use the concept of change in y over change in x gives you the gradient. That is y minus 17 over x minus 2. That is changing. This is changing y, this is changing x. So x minus 2 equals the gradient which we already have as 24. The gradient is 24. And if you simplify that, you have y minus 17 equals, multiply both sides by x minus 2. We shall have 24 x minus 2, which is y minus 17 equals 24 x minus 48. 24x minus 48. So then finally you will have, if you add 17 on both sides, you will have y is equal to 24x minus 31. Minus 48 plus 17 will be minus 31. So that is the final answer, which is the equation of the tangent. The equation of that tangent at point x is equal to 2 is y is equal to 24x minus 31. 24x minus 31. My dear learner, I will stop here for today. What we have learned today is how to find the equation of tangent to a curve at a particular point. And what are you supposed to do? We first differentiate the equation to get gradient function. The gradient function will give you the gradient of the curve at that particular point. The point must be given. Then that gradient of the curve at that point is equal to the gradient of the tangent. And since you know the gradient of the tangent, and that tangent passes through that point, so you can get the equation of that tangent, because equation of a straight line can be obtained if you have a point on the straight line and the gradient of that straight line, using the concept which you learned in Form 2. So just like our previous lesson, I want to leave you just one question as assignment, and I want you to try. So I want to leave one question as assignment. I want you to try the question, and we shall look at it at the beginning of our next lesson. So this is the assignment. Write down the assignment, my dear viewer. Find the equation of the tangent to the curve y is equal to x cubed plus 6x squared minus 3x plus 1 at x is equal to 0. That is the assignment. Find the equation of the tangent to the curve y is equal to x cubed plus 6x squared minus 3x plus 1 at the point where x is equal to 0 on the curve. So that is all for today. Have a nice day. Bye-bye.